All right, let's look at the homework 3.1, problem number 6. All right, so where does the normal line to the parabola at negative 1, 0 intersect the parabola a second time? All right, so first we need to find the normal line. So let's do that. All right, so we want to find the normal line at this point. So we already know the x1 value, let's see, I've got the wrong thing. Right, x1 value is negative 1 and the y1 is going to be 0. Alright, so let's find the slope of the tangent line first, then take the negative reciprocal to get the slope of the normal line. Alright, so if you take the derivative, so y prime is equal to, derivative of x squared would be 2x, and derivative of negative 1 is 0, so this is it, right? Then in order to find the slope, so m is going to be equal to, right, y prime, and then you plug in negative 1. So this is going to be 2 times negative 1 is negative 2, right? But we have to take the negative reciprocal, so actually maybe I shouldn't have called this guy m, right? So which means that the slope that we are looking for, slope of the normal line, is going to be negative reciprocal of negative 2. So slope is going to be positive 1/2, right? All right, so the normal line equation is going to be y, so this tells you that the y minus y1 is 0, so we didn't really have to write that. And then m is 1/2, and then slope is x minus negative x1 is plus 1, right? So we have the equation of the normal line, so maybe we can just clean it up. So this is going to be a y is equal to 1/2 x plus 1/2. Right? Then we want to know where this normal line intersect the parabola second time around. Right? So we can just set them equal to each other. So we have x squared minus 1. Right? Set that equal to 1/2 x plus 1/2, right? Right, then let's see, I don't want to deal with a fraction, so I'm going to multiply everyone by 2. So you get that 2x squared minus 2 is equal to x plus 1, right? Then I'm going to bring everyone on the left-hand side. So I'm going to subtract x and subtract 1. So you get that 2x squared, right? And then we're subtracting x and subtracting 1. So it's a negative 3. And then there's nothing left on the right, right? Then we can factor this out. So we know that the other one is going to be x plus 1, and then this is going to be a 2x minus 3 is equal to 0. So obviously x is going to be equal to negative 1, and let's set that equal to 0. It's going to be 3/2, right? So negative 1. Right, so negative 1 is the point of tangency. We're talking about this point. So we have to keep 3/2 because we want the second point. So negative 1 is for the first point. All right, so since we already know that the x value is 3/2, all you have to do is you can use the y is equal to original parabola. So if you plug in 3/2 into the x here, and a minus 1. So this is going to be 3 squared is 9, 2 squared is 4, and then you're subtracting 1. So 1 is 4/4, so it's going to be 5/4. Alright, so the point that we're looking for is x value is 3/2. and then corresponding y value is 5/4. Right? Let's type it in. All right, so we got 3/2, comma, 5/4. All right, let's check the answer. All right, it came back and looks like we got the point correctly. All right, so let's find the correct picture. All right, so you have y equals x squared minus 1, so it's facing up parabola. So you can see that this one is facing down, so we can eliminate number 1, and we might be able to keep this one, and this is okay, but you can see that the fourth one can be eliminated. So it's going to be between graph number 2 or number 3, right? So let's see if you look at the other intersection. You can see that it's 3/2, 1.5, and 5/4. And here, this is obviously not the correct point. And if you look at this one, right, so 3/2, so you have a 1.5, we have that. And then you have a 5/4, so you have, this is about, 5/4, or 1.25. So this is correct. This is the correct picture. All right, let's check the answer. All right, I came back and looks like we have the correct picture as well. All right, that's it. I hope that this was clear.